All right. Hello, everyone. Welcome to Creation of Game Society Game Dev 101 Workshop. Today, we're going to talk about a lot of things, mostly just overviewing a few things that will relate to your beginning paths of your game dev journey. It doesn't cover everything, but it'll cover enough to kind of give you a good start into creating your games, into what a game is, and to basically how the game ecosystem sphere kind of works in terms of ideas, right? So, first off, let me change the slide. Sarah, kick us off.
Hi guys. Oh, sorry. Hi guys, I'm Sarah. I'm the event coordinator and I host some workshops in COGS. So we're gonna start off with kind of talking about like what is a game? How do you define a game? So basically, a game in its most simplest terms is an interactive experience for what we call a player, someone who is playing your game. It could be one person, it could be multiple. And a game can really be anything. You know, you can use it to tell a story. It can be a work of art. It can be used to promote like competition, like sports. Sports are games. Or it could just be, a brain puzzle kind of game. So a video game, you basically that's when you translate the game over to something on a computer or some sort of electronic device. Basically, it allows you to be more creative with how you visually represent your game, how the player can interact with your game, and usually there's some sort of end goal and you give the player tools to get to this end goal. Like for example in this screenshot for a game like Doom, the end goal is to kill all the enemies, get to the end, and so you give the player weapons, you give them, other types of tools that you can use to take out enemies, and this is all done through an electronic device.
So now that we have a kind of good understanding of what a video game is specifically, here are some ideas that you want to take away when you're making your video game. So do make something enjoyable and fun to play. So the first thing with this is that you want to add creativity and make it flash, right? This is one of the best ways to kind of make it enjoyable and a little bit more funner. When you're playing a game, you're not just playing a mechanic specifically, you're playing a mechanic that is kind of padded up to feel nicer, right? So, for example, if you have a game about shooting, you can just simply have a line that comes out of the player and hits something. But in order to make it flash and creative, and in order to make it a very fun mechanic, a very nice creative mechanic, you can add things like muzzle flashes, sound effects, or like some hit indications, right? This is a good way to kind of get a solid understanding of what your game should feel like at the end. So this is not something you should in the beginning, but once you get past the beginning stages of making your mechanics, adding some creativity, making a flash is kind of what you want to do to make it more appealing of a game. Next up is going with the flow. So this relates more to ideas. When you're making a game, there's ideas constantly popping in your head, left and right, left and right, left and right. Now, if you're strictly following a path that you've created in the beginning, you're going to be constantly working on that to the end, and that's okay. But then there will be times during your development path that you feel like, hey, this idea is fun, or hey, this other idea is fun, or maybe I want to change this, maybe I want to add something, maybe this bug I can make it into a feature, right? These are the type of ideas that you want to kind of maybe test it out a little bit and see if it's fun or not. Because going with the flow makes your game feel more natural in the terms of the development cycle. Because if you're making a game that you design in the beginning and you kind of don't like the design but you want to finish your game, you kind of lose that flow and you kind of just like make a stale game that you probably don't like. But if you kind of adjust and change up your game as you want it as you go, then it makes it much more of a funner experience to make and also probably a funner experience to play. Next is trying to invoke emotions for the player. So emotions are very generic in terms of what I'm talking about. It's not just storytelling emotions, but just general emotions people feel throughout the day, right? If you're making a game and you're making a fun mechanic, but it's just a mechanic, that's okay. But in order to really make your game pop and make it fun, make it enjoyable for everyone, there's always this sense that you probably should add some more things to kind of aim for when it comes to the player's enjoyment, right? So, for example, if you're making an arcade game, you want to make it fun, exciting, maybe a little bit quick, maybe a little joyous, maybe fun to watch. If you're making a racing game, you want to make it feel like, oh, I'm constantly on the time. I'm constantly like, I need to go and finish this race. Otherwise, it just feels like you're just driving down the highway and just getting from point A to point B. Next up is like horror games. Specifically, horror games are like the best example of trying to evoke emotions for the player because you're making a game that is all about emotions and playing with the player's emotions, right? You have a player go through an environment, do some mechanics, some puzzles, but there's always this sense of fear, this sense of a little bit of stress, maybe a little bit of unease. But the idea is not to like overwhelm it, and also add some intrigue to that. But these kind of emotions you get from horror games are something that you probably want to show off in other games, but in a more general sense, where like you make your game not just for the mechanic, but make your game also for the player to feel something from your game, because that at the end of the day makes your game more brighter, right? Um, Last thing for this do is test your core mechanics. When you're making a game, you're gonna have a few mechanics that are the best thing that the player will see throughout the game, right? Or the only thing the player will see throughout the game. These kind of mechanics you probably want to iron out in the beginning of the cycle of game development. You kind of want to see, okay, sit down, you have your mechanic of maybe, let's say you're doing some parkour. Okay, we have some parkour mechanics. Let's implement it first and try them out by prototyping, which is a very important thing to do, to test if, hey, is how long is this gonna take? Is this very more bigger than we think? Is it fun right away? What are we missing? What is the core mechanic missing, or is it not even a good core mechanic? Right? Prototyping in general is a great way to kind of iron out these ideas, these problems that you might run into in the beginning of your game development cycle, so that when you build up your tower, if your tower is based on something that is broken and not fun and is bad, the whole tower should just collapse, right? So prototyping, do that through your engine, do that through arts and crafts, do that in person, anything, anywhere, D&D, LARPing, whatever. But the idea is that prototype your ideas so that when you get to the mid stage to end stage, you have a good foundation to work with, right?
So, one of the lessons we really want to impart to you guys is just don't make something gigantic for your first game. Like, read the text that is on the screen, internalize it, say it every night before you go to bed. Do not make something complex and huge as your first game, because then you're going to run into this slide right here. You're going to have too many ideas and you're going to try and implement it all, and there's going to be some consequences. When you're trying to brainstorm what features you need for your game, you should really be thinking about what is going to elicit the target emotion. You might have some really cool ideas for other things, but if they don't fit for the game and they don't really make sense for simply conveying that emotion, you're going to run into something that a lot of people call feature creep, which is basically where you have tons of new expansions and additions of all these features, and it could be software, video game, anything. And they basically go beyond like the basic functions that you're trying to do. And it leads to stuff like overcomplication, it leads to delays, it's just bad stuff overall. You really want to focus on getting a message across as simple as possible so that whoever your target audience is able to navigate it smoothly and the game isn't too complex for them. Another thing we want to touch on is collaboration. You guys don't have to do everything by yourselves. I know that it's very tempting when you have a really good idea for a game is to work on it alone because you think that you know what's best for your game and you think that you can make your game the way you think it should be by yourself. But in reality, making a game is so much easier and so much quicker with a team of people. You know, you should get used to asking for help and communicating with people. The way you can make a game the way you want it to be is just through communication. You know, making sure that everyone understands what the game is about. What are the main mechanics? What emotion should our player be feeling? How do these mechanics work? You have to be able to communicate this effectively to a team so that you guys can work together and make a product that everyone is satisfied with. And the most important part is Game development can be extremely overwhelming. I mean, just from what we've gone over, there's a ton of information, and we haven't even touched on like how do you actually make a game, what kind of engines you use, what kind of art. It's a lot. You have to make sure to organize yourself and just generally try and ground yourself every once in a while when you're developing a game. We have some things on here that are examples of project management where you basically organize your tasks based on what needs to be done, what is in the process, and what is done. Things like these can greatly reduce any stress and something like burnout and overwork by having a clear idea of what needs to get done. Because when you have a lot of things to do and it just turns into that amorphous blob of stress in your head, and then you just burn yourself out, that's what you want to avoid when working on a game. And that's one of the lessons we want to impart into you.
So now that we have a good understanding of things that you could look out for in a game while you're making a game throughout the whole like game development stages, now we're gonna talk about what's in a game, right? So the first thing you want to worry about in your game is a game loop. Now, every game has a different game loop, and game loops can be very small in size, a little bit bigger in size, and the idea I want to focus on is that what is your player doing throughout the game constantly? That is your game loop. There's different layers to this. So you have your first layer, you have your second layer, and then you have your third layer. But the idea is that your first layer is the most important thing you want to focus on. So by thinking about what your game loop entails, you can think about what are the core things you want to make fun and worry about first, right? So these are your core mechanics. These are the core things your player is doing. So let's take a look at the examples we have here. So RPG. What's the core loop of an RPG? You kill enemies, you get stronger in most RPGs. Endless runner. What do? You run far, you improve the runner, and then you keep running far. Tower defense. What do? You protect your, that should say, headquarters or base or whatever. But you protect something, and then you upgrade your towers to protect that something. And you keep going back and forth, back and forth. The idea in the game loops is that you want to have a steady idea of what you want to focus on, so that at the end of the day, these ideas can be improved upon and made funner, and are your main kind of like sets that you want to think about. So, for example, if you're making an RPG and it's all about killing enemies and getting stronger, you can go ahead and do that, and improve on those parts, kind of worry less about the other parts. For example, of like, oh, how long is a player traveling between stages, or how long is how much money is the player spending? What's the amount of money the player is spending throughout the game? You don't have to worry about those parts. You can worry more about the core mechanics so they're fun, and then you can fix the other things that you need to fix later out down the line.
And going along with game loops is game flow. So when you have a lot of these game loops, you might have multiple in one game. You want to make sure that the way of progressing in your game is pretty clear to a player. You want to make sure your game has a linear feel to it. Obviously, if you don't want your game to be as linear, you don't have to do a super linear path such as like a story-based game, but you still want to communicate to the player what should they do next. This picture we have, a picture of like the Minecraft progression. If you're a longtime player of Minecraft, you start out chopping trees with your hands, you get your pickaxes, you upgrade, and you just go from there. Your game should be built like that, where there's a clear way to progress in the game, and you're not having the player just left wondering, what do I do to progress?
Awesome. Next is game design and planning the specifics, right? So when you're planning your game out, this should be the first thing you do before programming, before making art, before making sound. Plan what your ideas are and how you're going to organize them first, right? Now, the main solution for this is the game design document. Now, the game design document is usually one document. It doesn't have to be one document, but usually is one document overviewing literally every aspect of your game. For example, what art style are you going for? What lore is in your game? What's the story going to be telling? What's the setting? What mechanics are you going to be making? What are you going to be programming with? What engine are you going to be using? The game design document should hold everything that the team members working on a game or yourself. You guys can look back on the game design document and you guys can figure out what the game is supposed to be doing or what the game is. Because while you're working on a game, you have a whole to-do list that you're kind of like just crunching through. But at the end of the day, you kind of may lose sight of what the game is supposed to be. And having one document or having a set of documents that you can look back on and read and double check your ideas are straight is very important. Not only for yourself or for individuals, but for you to kind of work better throughout your game. So if you're making one mechanic and you spend a month of it on it and you kind of lose the idea of what your game is, that's what the game design document is for. Or also, if a new team member comes in, you can just hand them this document and they can read through it and hopefully instantly pick up, oh, this is the game. Here's some specifics. Let me build on top of that. Now, the game design document shouldn't be a huge deep dive into every single thing in your game like a textbook or anything like that. It should be a good overview, and then you can probably make other documents to detail like, oh, the lore, oh, the mechanics, oh, the stories, oh, the art, and stuff like that. But the idea of the game design document is that you have all your ideas centered around one area so that you can always come back to that one area and look at your ideas and kind of rejuvenate your brain with what your game is, right? Now, for those of you who program, this could be more specific to you. After you design the game, after you design the mechanics, you start prototyping, making your game, and doing all the stuff in programming stuff. The idea with planning programming systems is a little much of the same, where you kind of like get a good overview of what you're doing, and then you start making it. But that something you gotta worry about is how are you gonna program your game, right? So when you're programming your game, outline most of the systems that you're gonna start off with, and kind of think about how exactly you're gonna group them, you're gonna set them up, and kind of get a good overview of what you're making instead of just like jumping right into it. This is more related to after the prototyping stage. When you're prototyping, you can probably make a little more of a mess, but when you're making your full game, try to keep it clean and easier for you in the future to work with. So that's what you want to worry about when programming systems in a game, right? So a good few examples are, first off, keeping your code clean, make sure you can read your codes, keeping your code organized. Please don't have scripts just jumbled out everywhere or just like put into the root file folder of your assets, like or of your whole game project folder. When you're programming your game, you should have a good set of files or folders that kind of group your systems together and keep it organized so that you can constantly go back and see, oh, where's the player health system? Oh, it's through this file and through this folder, through this folder, and there it is. Oh, where's the trigger stuff? Oh, it's through this folder and this folder. The idea with programming is that you want to constantly make it easier for you to program and not make it a web of stuff that makes it harder to program. There's a few more things on here like build expandable systems, which is something that you will kind of grow into and kind of learn and kind of see what it means to be an expandable system as you program more and more in games. But the idea with expandable systems is basically do not reuse codes. Try to reuse code as least as possible, or as most as possible, because when you reuse code, you can not worry about overworking and constantly making new pieces of code that do the same thing as your old pieces of code, and yada yada. So with expandable systems, that's what you're trying to do. Try to make things stackable, and by doing that, you kind of also make it more designer friendlier, where a game designer can come in, pick up a system, drop it into a different system, and they work together really magically, like really nice. That's what you want to do with expandable systems. There's also, don't worry about your performance unless it's unplayable. So this is very important. Do not pre-optimize, because pre-optimization can waste a lot of time. When you're making your mechanics, like for example, oh, I'm making the player shoot stuff and there's enemies and everything. Oh, I'm making the enemies now. Okay, let me make a few enemies. Let me optimize a few enemies and let me send it off. And what this basically does right there is that when you make your enemies and optimize them as you're making them, you're kind of wasting time, because in the future, if the enemies you make are like very bad enemies and the code you made doesn't fit what they needed, you're most likely to not have to like kind of just redo the whole system. So all that time you spend optimizing may be helpful for learning in the future, but it's not helpful for saving time, so that you don't overspend your time on one specific thing, right? So overall, programming systems, there's a lot to worry about. Simple base ideas, just keep it clean and make sure at the end of the day, there's nothing where you're spending too much time in, right?
Yeah, going along with that, after all of that programming information, you're probably going to want to do something similar for the art of your game. I would say early on in your game, you should probably have some sort of cohesive art style that you're going to stick to, whether it's going to be 2D, whether it's going to be 3D, high poly, low poly, basically how detailed the 3D models are, just so you can have an idea of the art style you want. That way you can keep it consistent throughout the game. Especially if you have multiple artists working on your game because everyone has a different art style. You want to make sure you stick to one art style that the other artists can emulate so that your game doesn't look too disjointed when it comes to all the different kinds of artwork that you have in there. You know, if you're pulling models from a free asset store and you're having your friend make other models for you, the models from the asset store and the models your friend makes from you probably will not look the same, and this will be kind of weird looking to whoever plays your game. So, one thing you should definitely do is find a style that you want to do, stick to it so that your game feels cohesive. It feels like it is one game rather than a bunch of different things patched onto one another to make a game. And the same thing for the story. Um, when you write a story for the game, it's just like writing any other kind of story, you know? You want to follow the conventions for writing a fictional story. You know, we all know the structure by now. You have the beginning, you have, rising action, climax, falling action, and the ending. And it's really important to have this all mapped out before you even start your game so that you don't have to write the story as you go along. Make sure you don't go too overboard with the story for your game unless it is the key component of your game. You know, you want the mechanics of the game to come first because as great as a story can be, if the gameplay isn't compelling enough to the player to make them want to sit down and play your game, they will never know what the story is because they just can't be bothered to play your game because either it isn't fun, there's too many bugs, it's just not a great experience. So, when making a game that's focused around a story, you want to make sure the story comes secondary to the mechanics. Of course, this is different if the game is something like a walking simulator, where the main point of the game is you walk around and the story is given to you, or if it's something like a visual novel, where the gameplay is majority dialogue options. Unless you're building one of these, it's really, really useful if you hammer out your mechanics first, and then you use those mechanics to tell the story, rather than the other way around. And finally, sound and music. You're definitely. Oh, wait, no, I lied. Not finally. Wait, no, I am lying. Yes, finally. Sound and music. You definitely want to pay close attention to the kinds of music and sound effects that you have in your game. Sound design is a whole other field that, there are teams of people working on sound design. But you definitely want to keep it in mind when you are making your game, even if you're not really an audio kind of person. What kind of environment is your game taking place in? Is your game taking place in an underground laboratory? Is it taking place in a deep woodland forest? You want to tailor these sounds towards what your game is. Same thing for the music. You want to make sure that the music fits your game. You don't want to have like these swelling orchestral pieces meant for a woodland forest when your character is exploring some underground laboratory. And the sound effects, well, you can't have the sound effects for an underground laboratory in the middle of a woodland forest. It just won't work. And that's why it's so important to, if you do have a composer working on your game, you want them to be included in all the discussions of the design, the story, the art, so that they can create a piece that reflects your gameplay. Because after all, the games that have great sound design, people enjoy playing it because it's just like a very enjoyable experience for the ears. It elicits the emotions that we want. Next slide. So now we're going to get into what kind of things can you do to actually create a video game. We're going to go over stuff like engines, and the programming languages, and just generally the structure of a video game. So the first thing before you create your game, you should know the general gameplay of it, whether it's going to be a visual novel, a platformer, a first-person shooter, 2D, 3D. By figuring this out early on, you can pick the engine that's best suited for your game. We're going to talk about engines in the next slide. But for example, if you're making a 3D game, you know, a game made in Unity or Unreal Engine, that's going to be what you're going for, something in Unity or Unreal. If it's a 2D game, you can use an engine like RenPy. You can use something like Game Maker or Godot. Definitely hammer out the details of how your game is going to be played before you pick your engine, because each engine is specialized for different things. You know, if you're making a visual novel, you probably don't want to make that in Unity because Unity is not really configured great for with the tools needed to make a visual novel. But another program like RenPy, it's built from the ground up to be a visual novel engine. So knowing keeping the sorry. Keeping the main gameplay style of your game in your head before you choose the engine is extremely helpful. I'm very tired.
No worries. All right. So three popular game engines. Now these are kind of like your top three or the key three players. That one of them is currently growing, but two of them are at least like rooted in the game dev industry. Um, so you got Unity, you got Godot, you got Unreal, and with these game engines, they're not all of the game engines that you will see throughout your like game development lifespan. Um, there are some of them, right? There's a lot more, like Sarah mentioned, RenPy. Uh, there's LibGDX. There's Game Maker. There's even I think there's a Scratch game engine where you just drag and drop blocks of code into. There's a bunch of different types of game engines that are suited for whatever you need to, but I'm just gonna talk about the three popular ones real fast. So Unity is our main game engine we're gonna be talking about throughout the semester, and within the club atmosphere because it's a all-around engine that can do a few things that I'll talk about in the next slide, but it's what we'll be using throughout the semester. Then there's could be Godot, where we're gonna do one or two workshops on it because it's really up and coming. So if you want to learn about some of the things about Godot, Alan, who just joined, will be doing a workshop on Godot. But it's like Unity, but little bit more different. But in terms of this tool set, you can do similar things. And then there's Unreal. Now, Unreal is a different beast of an engine. It's very suited for 3D graphics. It's very suited for creating AAA things. But since it's not suited for our type of development, where in COGS we do a lot of like indie style development, we won't be touching upon Unreal. But if you want to learn about Unreal or learn more about it, go give it a Google search. Go see what it does. Go see how it feels. But like I said before, it's not a good engine for our club, so we're not going to be talking about that. But if you want to use it for a project, go right ahead. Um, the only engine I'm going to be talking about right now is Unity. Unity does a lot of things. That's why it's kind of great for our club. It supports 2D games, it supports 3D games, and that's basically the whole encompassing idea of games. If you want to make text-based games, you can do that in 2D. If you want to make like fancy little shading games, like with like artistic style, you can do that in Unity. A lot of artistic games are made in Unity too, or on their own engine. But the idea of Unity is that it's simple enough where it works for you guys as beginners or someone more advanced, right? It's an all around engine that works enough to a point where you can get something started really fast or fast enough to kind of create a game within a semester or 2 semesters. Another point is that if you know programming, if you've taken any of the Rutgers computer science courses, it's very easy to get into because it uses C sharp, which, like I said, if you know Rutgers TS courses, then you'll easily translate those ideas into C sharp because it's a very easy language to learn. It's like Java. There's nothing too advanced with it. There's nice features, but overall, it's a very simple language to kind of program in. It's also very easy to get into. It's free. There's a lot of different versions of Unity in terms of like, do you want like HDRP, URP, 2D, 3D? There's a lot of different packages you can use that are free. There's a lot of stuff you can do with Unity that makes it easier to get into because some of the stuff that you may want to make has maybe already been made already, and then you can import that into Unity and try it out. There's also lots of resources and tutorials. Like I said, resources, assets, things that you want to use. There's that in their Unity asset stores. Tutorials, there's a lot of those. If you search them on YouTube, you'll find a lot of them. We'll be doing a lot of that during our semester here at COGS. And there's just overall a lot of things that you can do with Unity that can be taught to you if you just search it up because there's a lot of people that use it. And last of the points is that it has good graphics. Now, depending on what you do, it might not have the best graphics, but it has good graphics. Especially since they updated the engine to do this whole new rendering pipeline thing with like AAA graphics or just like very easy graphics that can run on anything. There's a lot of graphical options you have with Unity. It's not just okay, a 3D game in Unity looks like a 3D game in Unity. You can change it up to make it feel better and less Unity generic, right? So in terms of good graphics, it has a lot of those. So that's why we're kind of using Unity as our go-to engine for COGS.
Yeah. And this last slide is just really quickly overview of video game design. How does it work? The main components of a video game is checking the input. This can be from a keyboard or a controller or some other input method. And then from there, you calculate the game changes. So, for example, if the player presses a button and you have to calculate how many steps will the player's in game representation walk. And then from there, you have to render those changes on the screen. And each of those changes is called a frame, and those frames loop. And that's basically what the game engine is going to do for you. It's going to check those inputs, it's going to calculate what in the game is going to change, and it's going to render that for you. So obviously, when you're picking your game engine, you want the calculations and the rendering to be accurate to what you're trying to actually portray in your game. And Unity is a great all-rounder for that kind of thing. It's fantastic, has a built-in physics system, great for beginners, great for professionals too. So we will be doing many Unity workshops, and we're going to get you guys comfortable with Unity so that you can develop your games and you can make something that you're proud of. And with that, that is the end of the workshop. Woo!
Awesome. So with the end of the workshop, I hope you all learned a lot about game development if you haven't already. Now, before we end it off, is there any questions that y'all have about game development? Anyone? Muffin Crow, you got anything?
Oh no, I was just unmuting.
All right, no worries.
Oh, I was
Oh, sorry.
I was gonna ask. I'm more of an art guy than like a code or computers guy. Is there any good resources to either either is there going to be like opportunities to work in a team where I can use that skill a little bit more, or are there going to be resources to like get more familiar with engines, with programming language? Because I'm like a STEM like a different side of STEM than computers.
Yeah, yeah. So is your question is that you want to focus more on art, and is there opportunities to focus on art, or both art and programming?
Both, basically
Both?
both.
Okay.
Definitely.
Yeah, there's definitely a lot of projects that are currently being hosted. So if you want to look at the project listing in our Discord and look at all the projects that are currently hosted, there's a lot of people that need people that can do art or people that can do programming. So there's both sides to the coin. Specifically, if they're 3D or 2D, it depends on the project. If you want to join them and kind of get started with them, go ahead and feel free to do so. If you want to come in person to our in-person meetings, definitely do that, and then you can kind of meet the groups in person and kind of like shop around and see what's what. But in terms of opportunities, there's plenty of opportunities for that. Also, one specific opportunity, Sarah, do you want to talk? You want to talk about Scarlet Game Jam?
Oh, yes. So for anyone who doesn't know what a game jam is, a game jam is basically just an event where it's like a week-long period where you get in a team or by yourself, not recommended, and you basically make a game. And for that event, people definitely need game designers of all types. So there will definitely be opportunities for you to do both art and programming, especially at the game jam because it is, such a short period and a lot of stuff needs to get done in that short period. So you will be wearing a lot of hats, even with projects in COGS during the semester. You probably will have to wear a lot of hats because, you know, we're only how many members do we have?
We
I don't
have a lot of
remember.
members, but project sizes only like range from less than 10, which is not a
Yeah.
lot for a good sized game. Um,
So
also,
definitely expect to wear a lot of hats.
oh, for sure, for sure. Also, to add to that, if you want to learn more about like some art side or some programming side, we will have workshops specifically tailored for those different things. So we will have a pixel art workshop or a Blender workshop, depending on how the semester goes. We might have a programming workshop on how to like program in Unity and see how that works specifically. So just keep an eye out on workshops if you want to learn more. We'll post more announcements. Next week, Thursday, we'll have another workshop. In terms of what it is, it's not fully decided yet, but we'll have an announcement soon for that. Is that all good?
Oh,
That
and
was
to
a very
elaborate a little bit, the artists are always needed, especially since they're kind of the foundation for a lot of assets. And currently, like I just joined the Backrooms project, and they only have about 2 3D artists out of 8 members. So we're kind of lacking in that department. So we're projects are always in need of artists.
Awesome. Brugels, all that's all good.
that was a very comprehensive answer to my question. Thank you so much.
Thank you for asking. Is there any other questions? No. All right. Cool. Awesome. So, just a quick reminder. Please come to in-person meetings if you can. We will be in Redcore. We'll be hosting all the game projects for spaces for all the game projects to work on. Um, and yeah, I think that's basically it. Sarah, do you want to end us off with anything?
Nothing that I can think of. Just keep an eye out on the Discord for any events that we have, any workshops that we're gonna have. Thank you all for coming to our first one. We know it's a lot of information in such a short time, but we're hoping that this gets you guys kind of excited to make a game. And, we hope to see you at our meetings.
Thank you so much. Have a good one, everyone. See y'all later.
Yup. Have a good day, everyone.